Well, we're doing properties of reflection. This is lesson 12.2, and it's the summary side. Again, it's worth 5 points if you do all this. So let's go through it and talk about what a reflection is. A reflection is probably best equated to looking at yourself in the mirror. What you see in the mirror is the exact backwards version of you, a reflection of you. So when we reflect across a line, and picture it as making a mirror copy of it across the line. So the summary gives a pretty good example. It shows we got a figure, triangle PQR, and we're going to reflect it across the y-axis. So this is the y-axis, and we're going to reflect it, meaning we're going to do it. Literally, if you think about it, we're just going to fold it over, and that's going to get us across the y-axis. So here we got it. Sorry, one moment. That's what I get for starting these videos about being fully thin. So I got a piece of patty paper. Yay, patty paper. Now the great thing about patty paper is I can see through patty paper. So what I'm going to do with the patty paper is I'm actually going to draw myself my y-axis pretty carefully. Draw my y-axis and my x-axis. Then I've got this triangle PQR. So I can take this and fold it over this paper, if I can get a hold of the paper, and fold it over right at the y-axis. Let me see if I can make my fold here. So when I fold it over at the y-axis, I get an exact reflection. Can you see that through that side? Yeah, it's still there. So I get an exact reflection of what was there before I folded it. Hold it a little crooked. I get an exact reflection of what was there before I folded it. And that's what they show you here. Patty paper is available. I have lots of it. But remember, you're literally going the other side. And I want you to think about this way. When I reflect something, let's move to this example. When I reflect it across the y-axis, its position up and down the y-axis doesn't change. What changes is basically I'm multiplying every coordinate here by a negative number. So every coordinate here, the y stays the same, so literally I get something like, algebraically, a negative x comma y. So every x coordinate I have is actually going the opposite way. And there's the big ticket money. We'll put a little smiley face on that. Yay. Hey, that one actually looks kind of smiley. Let's put a tongue on him. Yay. Okay, now he's happier. And you should have a smiley face too. So I'm doing everything. So when I did this, the y coordinate was 6. The y coordinate is going to stay the same. But the x, which was 2 in this case, p is 2 comma 6. That's the coordinate for it. 2 comma 6. What it becomes is negative 2 comma 6. It goes the exact opposite way. Now think about this way too. It is 2 from the y line, so 1, 2. If I go 2 more units, 1, 2, I get the exact spot. So r is 2 from the line, and I'm staying on the same y coordinate. So 2 from line, 1, 2, 1, 2, and I get r. Or if you do the other way, r is 2 comma 2. R of the image is negative 2 comma 2. Same coordinate, except I've multiplied the x by negative 1. So I'm flipping it across. That is how this is done. So that's kind of the algebraic way. I like it for reflection. It makes it so much easier, and it allows us to do some pretty easy reflections. Let's do a couple of examples. I'm not necessarily going to use the tracing paper. I'm going to use what I've learned here, and here I got a point. I'm going to make my points more obvious. So it says I want to crest across the y-axis. That's important. Don't go across the x-axis. We're going across the y-axis. We're literally folding it across the y-axis. So I look at this point, and here's the y-axis, and I'm going to go with point B. And point B is 1, 2, 3 off the y-axis. So if I go the other way, 1, 2, 3 off the y-axis, I get my new point B with apostrophe. Same thing for the C. I'm staying on the same y-axis. So 1, 2, 3. I go the other side, 1, 2, 3, and I get my new point C. Over here I go A. I'm going to stay on the same line as it. Right now it's at y equals 3. So I go 1. Excuse me. So A, I go on the same line. it's y equals 3, so I go 1, 2, 3, 4, 5, 6, 7. I go to the other side. 1, 2, 3, 4, 5. Whoops, lost my count. 1, 2, 3, 4, 5, 6, 7. And go right there, and that's the new A. I get my handy dandy ruler out, and I draw the figure. And I end up with a perfectly reflected. Now this other one, I'm gonna do that. So that's the counting way. We already know the tracing paper way. It works really great. So I'm gonna reflect across the x-axis. So I'm reflecting across this axis, or I'm folding the paper this way. And I'm gonna use the negative. So in this case, the x coordinates are going to stay the same because I'm going across the x-axis. So x will stay the same. It's y that'll get different. So my coordinates will all be x comma negative y. So let's find these coordinates. So here I've got g, and g's coordinates is 2 comma negative 3. So what I'm going to do is multiply that. The 2 stays the same, but negative 3 is times negative 1, which makes it 3. So 2 comma 3. And that's my new g of the reflection. I do the same thing to h. I've got h is 1 comma negative 6. So I'll multiply, 1 stays the same. Negative 6 times negative 1 is 6. So it's 1 comma 6. So up here I go 1 comma 6, and there's my new coordinate for h. Over here I go f. F is negative 4 comma negative 3. And I'm going to multiply that negative 3 by negative 1, making it 3. So I get negative 4 comma 3. 1, 2, 3. And that's my new f. Down here I got j. J is negative 3 comma negative 6. So negative 3 stays the same. Negative 6 goes the opposite. Multiplied by negative 1 becomes 6. So it's negative 3, 6. So negative 3, 1, 2, 3, 4, 5, 6. 6. And that's my new, what is that, J? Can't see where I wrote. Yeah, it's J. My new J. And then all I got to do is connect my points. Alright, so you got 3 ways to do it. You can use tracing paper, you can just count across reflection, or you can use the algebraic equation. I hope that helps.